All right, so I'm going to talk a moment about when we have to insert absolute values into equations when we're dealing with square roots or even like with our exponent rules, because this is going to come up throughout mathematics, really in pre-calculus and as we're going forward. So there's a simple little rule that we kind of need to know to be able to know when we're going to be using absolute values. So if I have the nth root of x to the nth power, we know that with exponent rules, we can write this as x to the nth power over the nth power, which actually just equals x. And that's pretty straightforward with exponent rules to see that this is going to equal x, because n over n is going to reduce down to 1, and that's just x. Except that's not the whole story here. The whole story is that sometimes this could be a positive or negative, or sometimes it doesn't even matter. So we need to actually have a rule to kind of figure out when we need to use an absolute value or not. Because this is the scenario when we're going to have absolute values pop up into our answers. So here's the rule. If I have the nth root of x to the n, it's going to be what we call a piecewise function. My answer would be x if n is odd. And then my answer would be the absolute value of x if n is even. So what this actually looks like is, say I have the square root of x squared. Well, a lot of kids, y'all are going to just say, well, that's x. But that's not the case. Because in this case, my n is 2, because the square root's 2 and 2. So we don't know if this is actually going to be a positive or a negative. So this actually, the answer would be the square root. Is the square root of x squared is the absolute value of x. Now, if we have something like the cube root of x cubed, well, once again, we know this answer is going to be x. But because these are odd, we can do odd, because if we put a negative number here, it's fine if we get a negative number, and then we'll get a negative number. We can take a negative of a cube root, and that's perfectly fine. And this just kind of goes up over and over and over again. If we have the 16th root of x to the 16th power, well, that's simple enough. That's simply going to give me the absolute value of x, because these are even. Even, we come over here, n is even, so it's going to be the absolute value of x. So this is going to lead to some interesting dilemmas as we advance into mathematics, as we go further into pre-calculus, and as you get into calculus. This will have more ramifications, because then the absolute value of x actually has its own definition, because there actually a positive answer and a negative answer to both of those solutions. All right, so this is how we're going to be introducing absolute value of x. So sometimes you're going to see on the answer keys, or as we're doing solutions, you're going to get an absolute value in your actual answer, and it's coming from this rule. So let's look at a little bit bigger, deeper example of what this would actually look like, and go from there. All right. So I want to simplify this down, the square root of 16x to the 4th. So what I'm going to actually do is I'm going to rewrite this. I'm going to use some exponent rules. I'm going to rewrite this and get rid of the square root issue. So I know the square root, I can write this as now the square root of 6. Wow, that is horrible. That is horrible. I'm going to write this as the square root of 16x to the 4th to the 1/2 power. I can redo this again to the 1/2 power. So I'm going to have, let's see, 16x to the 4th to the 1/2 power to the 1/2 power. I can go ahead and multiply these as my power rule. I'm just, wow, I can't talk today. My power rule here. So I'm going to get 16x to the 4th to the 1/4. What this actually means, and I can actually break this up. This goes to each individual. We have 16 to the 1/4 and x to the 4 times my 1/4. This right here is in the form of nx to the n. This is where we have our piecewise function, x if it's odd, and absolute value of x if it's even. Well, if I look, I have an even and an even. It's going to be my even number. And then 16 to the 1/4, well, that's just simply 2 to the absolute value of x. And that, ladies and gentlemen, is my solution to it. So we can actually get absolute values into our answer. Now, let's say I restricted this domain. All right, so now, let's say I restricted the domain up here, and I have something on there telling you about how I'm cutting or restricting the domain. In this case, let's do with x is less than 0. Now, this step right here is not your final step. The absolute value becomes nothing more than an evaluation, analytical evaluation step. So we have to know the definition of the absolute value of x. Well, the absolute value of x is another piecewise function where we're going to do x if x is greater than or equal to 0, and negative x if x is less than 0. Well, here I have x is less than 0, so this is telling me I need to have a negative x. So I change my absolute value to 2 to a negative x, which would give me a negative 2x. And that would be the solution for all the numbers that are x, that x is less than 0. So yeah, this is going to lead to some very interesting answers and answer choices and some evaluation steps, some analytical steps that you're going to have to start doing. So it's not just a matter of, can I get down to this? Now I'm going to have to actually analyze the answer using my domain restriction to get the correct answer. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.